Alright guys, so we're going to be solving this question. So the first thing is this is a rule-based system and we're going to try and prove and disprove the inference of V using forward chaining first, then backward chaining. So for forward chaining, let's start with that. What forward chaining cares about is that you start from the known rules, then you try and work your way up to the goal position. So iteration one. Which of these rules will fire? We have our fact base as P, Q, and R. So look at the first one. If S and T in this in our fact base we don't have S or T, so we can't do that. If Q and R in our fact base we do have Q and we do have R, so guess what? Rule two will fire. So now our new fact base will have if Q and R then T. So T will be added to the fact base. Now, if P then S, this will fire. So row 3 will fire, leaving us with P, Q, R, T, and S. If U, then V. We don't have that, so we have to start again. So iteration 2. If S and T, we now have S and T in the set. So yes, row 1 will now fire. So our new set becomes if S and T then U. So P, Q, R, T, S then U. That's it. And this one already fired, this one already fired. Now this one, if U then V. Yes, now we'll fall fire because we do have U in this set. So we're going to add V to this set now. So that's our final answer. So yes, I forgot U. So yes, we can prove the inference of V using forward chaining. Now what about backward chaining? For backward chaining, right, you start from the goal, then you work your way up, forming sub goals. Let me just explain how you're gonna do it. So we start with our known fact space P, Q, and R, right? So you say we should prove V. So we go to our equation and then we find where V is. So you're starting from the goal. Okay, so if U then V. Okay, that means now we have to prove U. Then to write sub goal U. So try and prove U. Okay, you say if S and T then U. If S and T then U. Okay, do we have S and T? No, we don't. So sub goal is now S and T. Or you can just write S and T so you not confuse yourself. So let's try and prove S and T. If Q and R then T. Is there Q and R here? Yes. So if Q and R then T. So therefore T is now proven. And if P then S. Is P here? Yes. So therefore S is now proven. So since we have now proven S and T, guess what? U is now proven. So since S and T is proven by rule 2 and 3, and therefore that proves rule, what's this? Rule 1. So U is proven. And if U is proven, what does that mean? If U then V is proven, it means that rule, if U is proven, then rule 4 is proven, which means V has been proven. I know this one's a bit confusing, but you get the point. If you can prove U, then. And another way, in case you're confused, at this point where T was proven, you can rewrite the set again. And at this point where S is proven, you can rewrite the set again at this point. And then because this is the set, U is now proven. So at this point, you can now add U to the set P, Q, R, T, S, then U. And because U is not in the set, this is non proven. So you can now rewrite the set again to be P, Q, R, T, S, U, then V. So anyhow you want to do it. So V has been proven by backward chaining and forward chaining. Thank you for listening. Please don't forget to like and subscribe.